This is the Jim Henson Memorial at the University of Maryland, and I'm doing a LiDAR scan of it using this system here. We have a laser that is powered by an Arduino, and then a Raspberry Pi connected to a Raspberry Pi camera. And I have all of this on a tripod where I can change the angle at which the laser beam is pointed, so I can tilt this up and down as such, and that will change the angle of the beam onto the statue. In order to collect the data, I'm using a script called Data Collection 2. So when I run it, I input the angle of the sensor mount, and I check that by using my phone's measuring tool to indicate the degrees off that this is, and then I report that here. You can see that Jim Henson is pretty bright here, and the laser tends to not show up as well even with high exposure in the photos, and additionally higher exposure leads to more background noise being involved. So I have a friend here who's holding up a blanket to put Jim Henson and Kermit into shadow so that the image shows up better. One failure that we had is that in some of these images this window is quite bright, and that is providing a lot of noise. So something that we'll do in the future is have someone else, or either cover that window up with something before we start, or see if we can find an angle such that Jim is covering, the statue is covering all of the windows in the image. Here's a diagram of the statue, which is the blue, and Kermit is green, and Jim Henson is orange. And then we have a cone of vision for which we are sweeping the LiDAR scanner from the bottom of the statue up to the top of the statue. This diagram shows the rest of the views that we scanned. So I did one for the back of Jim Henson, so literally his back, he's kind of twisted to the side on the statue. Then we have one for the back of the statue, one for the left side of the statue, and because I wanted to get Kermit himself in more detail, I positioned the tripod much closer to Kermit himself and did a scan that was really just from the top of Kermit to the bottom and of nothing else. So these are the 5-point clouds that I filtered the extraneous and noisy points out of, and then combined together to generate one large point cloud. Here's a time lapse of us doing the front scan. So for each scan, I tilt the sensor to a desired angle, and then I measure it using the measuring app on my phone. I input that angle to the data collection script, and then it takes an image, and then we keep iterating. Here is a scan from the left side. So my friend here is holding a blanket to block the light from a large construction light that was kind of unavoidable. Some problems we had here was noise from behind the statue, so you can see the building behind it, as well as there's light from the right side of the statue that was more difficult to block, and that wasn't much of a problem in this scan, but it was a problem in scans from the back angles because it was hard to block with just one blanket.